Thank you for using Geomagic Essentials. Today we will be going over how to prepare and auto-surface a model in Geomagic Essentials. To start, let's import a scanned model. I will do this by coming up to the 3D Systems logo button, then selecting Import. I select the file I wish to import, then the software displays a unit pop-up. In this pop-up, I need to define which units I used when scanning the model. In this case, we'll leave it on millimeters. After the model is imported, the software displays another pop-up asking the user if they want to run the Mesh Doctor tool. This tool looks at the model and tries to identify any issues that may cause problems downstream. I'll select Yes to open the tool. In the dialog box, in the Analysis section, we can see the amount of issues it's found. Geomagic Essentials also displays these issues as red triangles on the model itself. I'll select Apply to run the tool and then OK to exit the tool. Next, I'll want to defeature some areas of the model. To do this, I'll use the Lasso Selection tool to select an area, then right-click and select the defeature icon in the pop-up. After defeaturing, I'll fill the remaining holes all at once using the Fill All tool. This tool automatically highlights all the open boundaries and fills them according to the settings in the Fill Holes group in the Scan Tools ribbon. I'll select OK to exit the command. Then, to verify there are no new issues, I'll run the Mesh Doctor tool one more time. Now that there are no new issues, I need to remove any disconnected polygons from the model so they don't create any issues downstream. To do this, I'll use the Manifold tools. In the Scan Tools ribbon, in the Repair group, I'll select the Manifold dropdown. Select the Make Manifold Open tool. This tool automatically selects and deletes any triangles with open boundaries. Now that we have a watertight polygonal mesh, we can auto-surface the part. Autosurfacing is the geomagic process to create a NURBS surface model. Autosurfacing consists of 3 different layers of spline networks. The first layer is called the contour curve network. The second layer is called the patch curve network. The third layer is called the grid network. All of these spline networks are connected to each other to create surface patches, which are fit all around the part. To start the auto-surfacing process, I must first right-click on the model in the Model Manager and duplicate the model. Then select the Model Tools tab. In the Auto-Surfacing group, select the Start Auto-Surfacing tool. This tool converts the mesh model into an auto-surfaceable model and activates the second auto-surfacing tool. Select the second auto-surfacing tool. This tool will allow us to specify the parameters of the spline networks. The first parameter we can specify is the geometry type. By choosing the mechanical option, we are telling the software that we want the first layer, the contour curve network, laid down in an area with high curvature. By choosing the organic option, we are telling the software to put down the first layer, the curve contour network, as efficiently as possible. In this case, I'll select organic. The second parameter we can specify is the patch count. By selecting the Auto Estimate option, we are telling the software to decide how many of the second layer network, the patch network, to place in between the contour curve networks. By selecting the Specify option, we are telling the software to get as close to the target patch count number as possible. In this case, I'll leave it on Specify. The third parameter we can specify is the surface detail. By moving the slider closer to min, we are removing detail from the resulting surface. By moving the slider closer to max, we are telling the software to retain more detail. In this case, I will leave it in the middle. The next parameter we can specify is the surface fitting. If we select the adaptive option, the tolerance field becomes active, allowing us to specify a tolerance the resulting surface needs to maintain. If we select constant, we are telling the software to get as close as possible to the surface of the mesh for a specific patch. In this case, I'll leave it on constant. Once I have these parameters specified, I'll hit Apply to create the auto surface model. Now that I have an auto surface model, I can view the layout of the curved networks by selecting the Display tab. Then in the Geometry display, I can turn on each layer independently, starting with the Contour Curve Network, the Patch Curve Network, then the grid network. Lastly, we can export the newly created AutoSurface model as a step file for downstream applications. Thank you for watching the demonstration on how to prepare and AutoSurface a model in Geomagic Essentials.